Hi everyone, in this video clip, I am going to explain to you what is limit and why do we need to use the limit. Okay, now, so look at this linear graph. Isn't a linear line is represented by the function y equals to mx plus c, whereby the highest power for x is 1. But look at the function fx here. It is x squared minus 25 over 3x minus 5. There is a quadratic terms over here. So why isn't this a nonlinear graph? Instead, it is a linear line. Okay, so we can actually simplify this and we will eventually get to the y equals to mx plus c. Okay, let me show you. So if I were to factorize the x squared minus 25, that is difference between two perfect square, whereby we can factorize in x plus 5, x minus 5 over 3 times x minus 5. And you notice that x minus 5 can be factorized. So we left with x plus 5 over 3. So isn't it, this is in the form of mx plus c? That is the reason we have the straight line. Now, however, on this straight line, when you see this white dot, that means this is not a continuous graph. That means there is a broken, there is a place here whereby this line, they are disconnected. Okay, they are not connected to each other. Why is it so? It is because according to the function, we have x minus 5 here, which means if I substitute x equals to 5, I will get something over 0. In this case, it's 0 over 0. Anything over 0 is undefined. That is the reason when x equals to 5, the y value, there is no y value because it's undefined. So there is a broken part here. Now, then why is limit used? We still want to find out what is the fx value when x approaches 5. So this is when we use the concept of limit. Limit basically is for us to find how much does the fx, okay, how much can the fx achieve when x approaches 5 in this case. So as we go, since we can't substitute 5 directly, so we will try to substitute the nearer value, the value that is near to 5. So we start from 4 and over 6, we go slowly nearer to 5 from both sides. So when x limit of fx, that means what is the value of fx as x approaches 5 from the left. And this one is when, what is the limit of fx? How far can fx go when x approaches 5 from the right? So that is the concept of limit. We are not looking for the exact value when x is 5. We just want to find out what is the value, what is the limit that the fx can go as x approaches 5 in this case. So as we go nearer and nearer, you will notice that the value that we get is very close to 3.3. Okay, let it go in a little bit. 3.34, 3.32. So 3.34, 3.32, they are approaching 3.33. As we go exactly 5, we can't find fx anymore because there is no value here. So that is the concept of limit. If we can substitute directly after we do something about it, that means we get rid of the 0 in the denominator by factorizing. So we have x plus 5 just now. After we factorize, we got this form, right? And after we factorize this, our fx is equivalent to x plus 5 over 3. So when we substitute here 5, then we will have 10 over 3, which is 3.33. So we use the limit when we cannot substitute the x equals to 5 directly. Okay, so we have to do something about it, and then we insert 5. Therefore, the limit of fx, that means the line, it can go up to 10 over 3 as x approaches 5. So this is why we need to use the limit. And we shall use the limit in differentiation, especially in the first principle. And how does first principle work? We shall look into the next video clip.